Today's notes are on dilation. So by the end, you will be able to use an algebraic representation to explain the effects of a given positive rational scale factor applied to two-dimensional figures on a coordinate plane with the origin as the center of dilation. So basically, all you're going to be able to do is take an original image on a coordinate plane and you're going to be able to dilate it. You're going to be able to make it smaller or larger using a given scale factor. Okay, so we are going to complete the following on the table to the right. Our first step, name the original vertices of triangle ABC. So if we're looking down here on our graph, we're looking at triangle ABC. When you graph it, you need to know what your ordered pairs are. So we're going to look at what are my x and y values for my original image. It's triangle ABC. So we're going to remember that you're going to walk to your elevator before going up or down to figure out what your ordered pair is. So A, I have to go to -3 on my x and +3 on the y. So the ordered pair for A is -3 for my x, +3 for the y. Okay, let's do that for B. So I have to go to +6 on the x-axis and down to -3 on the y-axis. So ordered pair B is 6, -3. And for C, x-axis is -3, y-axis is -3. So C is -3, -3. Okay, so that's the first thing. We're able to identify what those ordered pairs represent. All right, next step. Dilate triangle ABC using the given scale factors. So let's look at our second one here. It tells us that we have a scale factor of 3. Yesterday, when we were deciding what the scale factor was, we decided what is my original image, what has to happen to the original image to the new image. So is it getting larger? Is it getting smaller? What am I multiplying by in order to get from the first image to the second one? Today, they're telling us what the scale factor is. They're telling us that the scale factor is 3, and you need to be able to take that information and create the new image using the scale factor. So 3 is what you need to multiply by to get to your new image. So we're going to use the ordered pair of 3x and 3y because I have to multiply everything by 3 to get to my new image. Okay, so let's try the first ordered pair. Our first ordered pair is -3, 3. So I'm going to just plug those values in for x and y so that I can get my new ordered pair. I'm going to plug in, we have 3 times a -3, comma, 3 times a +3. So my new ordered pair, 3 times a -3 is -9, and 3 times a +3 is 9. Okay, so let's try the next one. I'm going to plug in 3 again, or plug in my x and y values, multiply them by 3. So I have 3, plug in 6 from ordered pair B for my x, so 3 times 6 is 18, and 3 times a -3 is -9. Now C, plug in -3 for x, so 3 times a -3 is -9, and 3 times a -3 is -9. I want you to try and do the scale factor of 1/3, and we're going to check it in just a second. So pause the video, try that out, and check 1/3. So 1/3, you're going to plug that in just like what you did for before. Okay, we have to decide what's happening. How do I get from my original image to the new one? My scale factor is 1/3, so I'm multiplying everything by 1/3. So my new scale factor would look like 1/3 x, 1/3 y. Okay, I'm going to plug that in. So I have 1/3 times a -3 and 1/3 times a +3. Okay, remember multiplying fractions, you're going to multiply straight across, and you would get -3 divided by 3, which is a -1, and 3 divided by 3, you get a +1. For b, you're going to plug in 1/3 times 6, which is 2, and 1/3 times -3 is a -1. For c, plug in -3. 1/3 times -3 is -1. And 1/3 times -3 is -1. Okay, now all we need to do, that was dilating our ordered pairs. Now it asks us to graph them in different colors. So on your graph, we're going to go to the green one first, our scale factor of 3. So our ordered pairs, walk to your elevator before going up or down. We have -9, +9. So on your x-axis, you need to go to -9 and up to a +9. Okay, you see there it has A with an apostrophe. That apostrophe stands for A prime. That means that that is the new image. It was dilated. Something happened to my original image to give me the new one. So that's A prime. B prime is at a +18. So x is +18. Y is -9. Should be down here. This is B prime. And C prime on our x-axis is -9, y-axis is -9. C prime. Okay, and you can connect all of your lines. And you should see that you're creating a similar figure to our original triangle. It's the same shape, but not the same size. It is now larger. It was dilated by a scale factor of 3. Okay, our second one, now we have a scale factor of 1/3. You're going to use the blue, our ordered pairs. Notice this one has 2 apostrophes. That's called a double prime. So graphing this, -1, +1 is A double prime. 2, -1 is B double prime. And -1, -1 is C double prime. Okay, again, we have a similar figure. We have a new triangle, same shape, different size. It is now smaller. Okay, let's look down here at, it says use an algebraic representation to describe each dilation. So when you had a scale factor of 3, just like yesterday, we were deciding what happens from our first image, which is xy, to the new image after it was dilated with a scale factor of 3. And we use the ordered pair 3x, 3y. So this statement right here is your algebraic representation, your original image to your new image. Okay, we also need to be able to identify if this was an enlargement or reduction. Okay, if we're taking our scale factor and we're looking at it, anything greater than 1 is an enlargement, anything smaller than 1 is a reduction. So since 3 is greater than 1, we call this an enlargement. Okay, let's look at scale factor of 1/3. For scale factor of 1/3, we multiplied our x by 1/3, so we have 1/3 x, and we multiplied the y by 1/3, 1/3 y. This is your algebraic representation. Okay, so again, we talked about if it is larger than 1, it's an enlargement. If it's less than 1, it's a reduction. And since 1/3 is less than 1, we call this a reduction. Your assignment from here is to fill in the observations. You have at least 3 sentences explaining what we learned today, and I will see you tomorrow.